Waypoints and markers are a popular way of outlining important objects or places in open world games, and not only. They are an easy method of telling the player, hey, take a look at this. In this tutorial, we will learn how to create a simple waypoint system that includes both the compass element and the on-screen one, similar to the one that you can currently see on your screen. If this is your first time here and you want to learn more about Unreal Engine 4 and game development, start now by subscribing so you don't miss anything. With that being said, let's begin this tutorial. Before getting into UE4, let's break this tutorial into 3 parts. The first one is making the compass. We have already done a tutorial on that topic, so I'm not going to create that once again. I strongly suggest you to go and watch that if you don't have a compass in your game yet, and then come back and watch this one. One more thing regarding that tutorial, I managed to create a better texture for the compass, which we will use in this video. Link to both the tutorial and the new image in the description below. The second part is making the on-screen waypoint appear and follow the initial location that was specified. Last but not least, create a widget that overlaps with the compass and displays the general direction of the original waypoint. The hard part here is making it rotate with the compass. Alright, now that we have everything planned, let's hop in Unreal Engine and start creating. Let's start things off by creating the waypoint. The first thing that we will have to do is to create a material. So let's go to content browser, material, and name this m_waypoint. Alright, let's open it. And the first thing that we have to do is to go to material domain and set this to user interface, and then set the blend mode to masked. Right, now for this material I already have my images in here, and let me show them to you. So this is the triangle, and this one is the same triangle but only the white part. Let's get this one in here and plug the alpha in the opacity mask. Then from the top pin with the colors we are going to subtract something, but we don't know yet what we want to subtract. Let's get a triangle alpha, and we are going to multiply this with something. Let's plug the colors in A and plug this in B. Now for B, we are going to get a color. The reason that we are doing that is because we don't want each waypoint to be white, we want each waypoint to have its own color. So for that we're going to get a vector tree, convert this to a parameter, going to name it color, and the default is going to be white. Actually we can go with red, so you can see better what is going to happen now. Of course, now if we are going to multiply this texture and then subtract from the original one, we are not going to get red. That is because we are going to, if we subtract from 1, 1, 1, we are going to subtract 1, 0, 0, we are going to be left with 0, 1, and 1, which is exactly the negative color. Let's set this back to full red, and in order to subtract exactly what we need, which is in our case 0, 1, 1, we will need to make this negative by using a 1 minus. So as you just saw, this was blue when the values were 0, 1, and 1, and by using the 1 minus node we are going to get the same blue color. Plug this in here and then this in the final color, and now you'll be able to see how this is red. And if I'm going to change this to the blue color right here, now it should become blue and this one should become red, as you can see. So that's what is going to happen here. Everything nice, we can close this down, but before doing that we should apply, and that's it. Now let's go on and create a new widget. So content browser, right click, user interface, and widget blueprint. I'm going to call this widget_waypoint. In case you're wondering what these two widgets are, well, this one is the compass, this one is the compass, and this one is the HUD. Let me close this down and then go to widget waypoint. Let's go to field screen and set this to custom and set the width and height to 50 both. Okay, let's drag in here an image. Alright, and now we are going to set for the image right here, we're going to set this material. And yes, you can actually do that. Fine. Let's set the sizes for both X and Y 50. So this is going to maintain its aspect ratio. And then for the positions, I'm going to go with -15 and then -25. Alright, now let me explain why these numbers. First, if you ever want to center something on the anchor point, which keep in mind is top left, you will need to have the size on that axis divided by 2 and then multiplied by -1. So if I'm going to go here, 50 divided by 2 and then multiplied by -1, you can see how it's still minus 25. And now the minus 15 actually, is there by trial and error, just experimenting with the value so you can get an accurate value on the screen. Now, of course, if you're going to use a different image, which you most likely are going to, you will need to try yourself and see which are the best values for you. Usually these are between minus 35 and minus 15, but again, it depends on the texture and how your widget is set up as well, based on the width and the height. Okay, let's go to graph. Let's delete pre-construct, and we're going to keep these two. Let's drag this down, and first we are going to create a color variable, which is going to have its type linear color. Alright, let's compile, let's make this editable and then expose on spawn. Let's get it in the graph, but before doing anything with it, let's get the image. Make sure that in the designer tab you have this is variable ticked. We're going to get dynamic material, and we are going to set vector parameter value. And if you remember, we named the parameter color, and I'm going to check just to make sure. Color, as you can see, and then we will plug color in value. The reason that we are going to expose this and make it editable, that is because when we will spawn the waypoint, I will want to be able to set the color. Then for event tick, although I don't usually use event tick, for this tutorial we will have to, and not only in this blueprint. If you want to try an alternative to event tick, if you don't want to waste performance on this, you can try using timers, but you're going to get a worse result with that, because timers aren't as accurate as frames. Okay, let's get another variable. This one is going to be actor, and this one is going to be a type of actor. Let's also expose on spawn and set editable. This is going to come in handy later, so don't worry about it for now. We're going to get location. Let's also get player controller. Then we're going to project world location to widget position. Plug in the world location to get actor location. Okay. Now for event tick, let's get a branch and set the condition to be the return value. What this return value does, it makes sure that the object, so this actor, is actually on the screen of the player, because if it's not, we don't want to run any unnecessary code. So what we will be doing now is to go to designer, go to canvas panel, so the root of everything. Make sure this is a variable, drag this into your graph, and then set render translation. So basically this is going to set the location on the screen where the waypoint is going to be displayed. Okay, and then just plug the screen position in translation. Compile, and that should be it for now. What we are going to do now is to see how we can manually set waypoints in our world, so that we can let the player press a button and set a waypoint for that object. First, let's go to edit, let's go to project settings, and then go to input. Alright, let's go to action mappings, and I'm going to call this create waypoint. And I'm just going to call this action, because we are going to have a function called create waypoint, and I don't want to get confused by these names. I'm going to set the button to Q, close this down, and now we can create waypoint action. So now we are going to do a nice line trace by channel setup, nothing too sophisticated. Let's get the first person camera, get the world location, so now we know where the line trace is going to start. Let's multiply this with a float. Okay, first we will need to get the 4 vector actually, and then we will multiply this with a float, and let's say 5000 should be fine. That's not too much, but just enough. We will have to add these two values, and that is going to go right into end. Okay, now first we will have to check if this hit, because if it hit nothing, then there's no waypoint to be placed or removed. We will also create a function for that. Okay, so if it's true, what we'll do is to first create a variable. I'm going to name this waypoints, and it is going to be of type actor, which seems a little bit weird, but bear with me for a second. We are going to link waypoints based on the actors that they are pointing at. So first I'm going to get waypoints, then I'm going to get a copy. Actually, I'm not going to get a copy, I'm going to find item. That's what we're looking for. Let's break the out hit, and I'm going to look for the hit actor. If this is different than -1, -1 is returned when the actor is not inside this array. So if this is different than -1, then that means that the waypoint does not exist and we are going to create it. So let's create a new function, create waypoint, but we are not going to yet set it up. We are just going to call it from false just so we don't forget about it. Then from true, we are going to do another check. That means another branch. Okay, let's get from hit actor. Let's check if actor has tag. The tag I'm going to be checking for is can't remove waypoint. This is a pretty long tag. If you can use something shorter that you will remember, and maybe your team as well, that is going to be better. The reason that I'm going to check this is because there are certain waypoints I don't want to be able to remove, such as the ones for quests. I don't want to be able to remove those. Okay, if it's true, then we are not going to do anything. Actually, it would be better if we are going to negate this. So if it has, then it is going to return false. But if it doesn't, it is going to return true, from which we are going to create another function, but instead of a function, we are going to use a custom event. I'm going to call this remove waypoint. Okay, and let's call it here. And now we're going to see how we are going to set this to up. But first, let me explain the difference between why we're going to use a function for create waypoint and custom event for remove waypoint. Functions can use outputs, meanwhile custom events cannot do that. You can maybe create a workaround for it, but it's not as great as the outputs from the functions which are already built in the engine. We're going to later use an index from create waypoint to store some other values. We're going to start creating these functions with the create waypoint because it's a little bit easier. The first thing that we will do is create widget node with the class, let's see, widget underline waypoint, and we can already see that we will need some inputs. So let's plug color in here and actor in here so we can create some inputs. And if we go back to event graph, we can already set the actor to be the hit actor. Okay, now I already have a reference to my widget underline HUD, which I showed earlier. This one, I created that by getting here create widget and then a set and then added that to viewport. I'm going to get this and then get canvas, which as you saw, this is also the root of everything. Canvas right here. And then I'm going to add child to canvas. This child is going to be the return value from the create widget. Okay, now let's go back to widget underline HUD and create a new variable. I'm going to call this waypoints, just as I did for the first person character. And I'm going to call this I'm going to set a type widget waypoint. Okay, and let's set this to an array. Okay, let's get the HUD. Then let's get waypoints. And we are going to add this. We're going to add again the return value. Alright. And then what we'll do is to get waypoints once again from the first person character this time. Then we're going to add, but instead this time, instead of the return value, we will add the actor. So we are going to have a reference to it. Next time we're going to try to create a waypoint. Alright. Then we will need an output. So let's create a new parameter. This one is going to be index. And this one is going to be an integer. Let's get here. And we're going to plug in the index this output from the add, which is going to return the index of the newly added variable in the array. This index is going to be used when we want to add quest waypoints. That is because, for example, for that, I would choose to use the blueprint of the level. So in that way, I can link the quest to the ID of the waypoint. Alright, now let's get back to event graph and let's go to remove waypoint. And one more thing, actually, before doing that, color, we're going to set that later. And we are also going to come back to both of these later and change something in them. So don't think they're done for now. There's a lot more to do there. Okay, let's go to remove waypoint. And here we will need some inputs. First, we will need an ID, and then we will need an actor, which is going to be an actor reference. Right. For the actor reference, that is going to be hit actor. Okay. And then for the ID, it is going to be whatever this find node returns. Now let me explain why that is. For the actor, there's a very simple explanation. First of all, if we also wanted to get the actor again, what you could do is to go to waypoints and get a copy node, and with the index that we just found, plug this in here, and then this in the actor. But that's a waste of performance. We don't have to do this operation. We can just get it from the hit actor, because we know it's the same actor, because we just found it in this array. And then for the ID, every time we are going to remove a waypoint, the ID is going to change for all other waypoints, right? So this way we can get the exact ID of the waypoint that we just found. We don't have to store that into another variable. Okay, so I'm going to get my HUD, and then I'm going to get waypoints. So what I'll do is first get a copy with the ID, and then I'm going to remove this from parent. So I'm going to remove that waypoint. Then I'm also going to remove index. Okay, let's make this nicer. Okay, with the ID, with the index, the ID that we are going to reference here. Okay, then we are also going to get waypoints and remove item, and this item is going to be the actor that we reference as well. Okay, so that should be it for now. We're going to come back later when we are going to create the markers on the actual compass, which are going to be displayed here, right? Then we will have to remove those as well. So let's see if we can actually try this out. Let's set a color here and play. Now if I'm going to press Q, you can see that there is a waypoint, right? If I'm going to press Q on that one, you can see another one with the same color, because there's nothing to change in there. If I'm going to press Q once again, it is going to get removed. If I'm going to press Q once again, this one is going to get removed, and I can just do this as much as I want, as long as I hit my target. Okay, and then I can just come and remove them. So everything is fine. Also, one more thing, if you were to do the tracking of the waypoint with the timer, this would be very laggy. This wouldn't be as accurate and would look very bad on sudden moves. Okay, let's close this down. And that is everything for the waypoints for now. So let's start creating the markers now. What you can do now is to go to m_waypoint and duplicate this, and just leave it as it is with that name. Then delete all of this and plug this in the final color. Now apply, and let me tell you one thing that I forgot to do. The reason that we are going to use here another texture is because if we were simply multiply this texture sample with a color, the gray area would get affected. Of course, in your case it might not be the same. You do not have to follow me entirely, keep that in mind. But for this one, since it's going to be so little, the gray isn't going to be so noticeable, so you will really have to stare at it for some time to notice it. Okay, we can close both of these down, and let's get another widget. I'm going to call this widget underline marker. Okay, let's go to fill screen, set this to custom, and width is going to be 1328 by 120. Again, these values, I achieved these values by experimenting. You will have to do the same in case this doesn't work for you. Let's get a slider. We are going to use the slider in order to shift the position from left to right and in center and the other values. Let's set the anchors to everything, so all of the corners, and set the offsets, all of them to 0. Okay, now let's go to slider bar color, actually slider handle color, and let's set this to something random. Doesn't matter for now, we will change this later. Let's go to style, and let's set a normal thumb image to the material that we just created. Okay, so now you can see it, but set the image size to 30 by 30, or something that is going to look good on your widget. And also make sure that these are going to be equal, so you don't get any distortions. Then for the bar thickness, let's set this to 0. We don't want to see any other bar there. And that should be it. If we go to value now, we can just do this, and it looks very nice. Okay, now we will have to see how we are going to set up the graph. Let's delete everything but the tick event. Now we will have to copy some code for now. I'm going to explain it later, just do what I'm doing, and everything will make sense at the end. Let's create a float here. I'm going to make this a slider value, and I'm going to set this to be a float. Okay, I'm just going to set it here, no value yet. Then I'm going to have a branch, and if that branch is true, what I'll do is to get a slider, set value, and the in value is going to be the slider value. Okay, now from false, what I'll do is to get a sequence. Then I'm going to get two branches. Okay, then I'm going to get a slider value, and I'm going to check if this one is not equal to 1 for the top one. If that is false, then we are going to set the slider value to 0. Okay, that's fine. Copy this. Now check for 0, and then again from false, copy this part and set this to 1. So I can roughly explain what is going to happen here. So first, we are going to do some heavy calculation right here, right? Which we haven't yet created. Then this branch is going to check if the object is in front or behind the camera, right? If it is behind the camera, then we are going to return false. If it's in front of the camera, it is going to return true. And then we can use this heavy calculation in order to set the slider value. Then if it's behind the camera, that means that there are only two possibilities of where this could be, to the left or to the right. And based on the value, on this value, we are going to determine that, right? So that is the general explanation for this. Now let's see how we're going to create that massive calculation and then check whether this is in front or behind the camera. Before creating anything else, let's add some variables. First of all, one called other actor, and this one is going to be an actor, as the name says. Then the camera actor, which is just going to be a scene component. Okay, and then a float variable called accuracy, which is going to be pretty random for everyone, depending on their widgets and how they are set up. But I'm going to explain that a little bit later. Let's create a macro, and I'm going to call this values to use. We will need some inputs. Let's create 3 inputs. Actually, what we can do is to get the camera actor, other actor, and accuracy, and just plug this in here. So this way we don't have to do that anymore. Oh, and one more thing. These are going to be set later. So accuracy doesn't matter for now. In a second we're going to set that, and the other actor and the camera actor will have to be exposed on spawn and editable, because we are going to set these once we create the marker. Okay, let's get back here. From the other actor, let's switch this a little bit. From the other actor, we're going to get root component. Okay, from the camera actor, we're going to get a lot of vectors. So we're going to get forward vector, we're going to get right vector, and then we are also going to get the world location. Okay, now with the root component, what we'll do is to also get the world location of this, and we will have to find a rotation, a certain one. So from get world location, find look at rotation. So now we will know the rotation between the world location of our camera and the world location of the root component of the actor. Okay, then let's get rotation x vector. So we are going to get another vector, and then we are going to convert this to a vector 2D. I'm not entirely sure how this conversion is going behind the scenes, but what I expect from it to do is to eliminate the z-axis and only keep the x and y, which is what we need, because on a compass you cannot see up and down, only the left and right. Now what we will do to this is that we are going to feed this into the output, and let's name this we can keep it the return value, but let's put a space in here. Right. Then with this one, we are also going to have a dot product, which I'm going to explain in a second how it works and why we are using that. Let's just complete the blueprint first. Okay, now let's get the right vector, and we are going to once again convert this to vector 2D. Okay, and let me put this below here and plug this in here. Right, now from this we are going to get a map range clamped. Okay, that should be fine. And then outRange A is going to be 0, outRange B is going to be 1. Then we're going to get the accuracy, and what we'll do with this one is to multiply it with another float, which is going to be -1. Okay, plug this in A, in range A, and then for in range B, just plug accuracy normally. Okay, let's compile this, and we are also going to plug this in the outputs. I'm going to call this, let's see, slider value. Alright. Then what we'll also do is to get the forward vector that we got here and plug this in the outputs again. And I'm going to call this facing. Just going to call it facing because this is the way the camera is going to face. Now let me explain what these two nodes do, because they might be harder to understand than these others, which are self-explanatory. Okay, let's get over map range clamped. We're going to get a value, and then we are going to clamp this value between in range A and in range B, right? So we're going to get between minus accuracy and accuracy, which, as I said, we are going to set later, and I'm going to show you what it does exactly. And then depending on that value, which is clamped, we are going to map it to 0 and 1. So let's take as an example a progress bar. If you had health going from 0 to 1, you would want to convert that for the progress bar to show the health to 0 and 1, because that's the values that progress bar take in them. Well, this is what this node does. So if I were to plug in here the health of our player, and then have in range A 0 and in range B 100, and then outrange A 0 and outrange B 1, we would get the conversion. For health, that is a lot easier to convert even by dividing that by 100, but for complicated values like the dot product, we will have to map it. And then we're just going to output that. Okay, and now let's see what the dot product does. In our case, the dot product is used in order to determine whether the object is located to the right or to the left of the right vector. That is why we are also going to clamp this between 0 and 1 and between the accuracy. Now let's get this macro in the event graph, plug in the other actor, in the camera actor, and as you might have guessed, in accuracy. Okay, now let's plug in the slider value, and now we will need to create a new macro, is facing object. And let's see how we are going to set this one up. First things first, we are going to set up the inputs. Let's go to inputs, create two new inputs. One is going to be a vector 2D, so just going to call this vector 2D, and then the other one is going to be a vector, and I'm going to call it the vector for lack of better names. Let's convert the vector to a vector 2D, and then let's make the dot product between these two. Okay, then from this one we are going to subtract 0.6, so 0.6, and then we are going to check if this is bigger or equal to 0. Plug this in the outputs, and that's it. So what we're doing here is checking whether the object is in front or behind the forward vector of the camera, and we're going to use the dot product again for that. If it's in front, a positive value; if it's behind, a negative value, and we're going to subtract 0.6 just to make sure that even if it's just a tiny bit in front of the camera, we're not going to take that into account. Okay, so we're going to get is facing object, return value in vector 2D and facing in vector, and this goes in here. Okay, Now what is left is to see how we are going to create these markers and how we are going to eliminate them afterwards. In order to create the markers, we will go into the compass this time, and we're going to create a custom event called create marker. Okay, now we're going to create a widget, and this one is going to be a marker. Okay, and now again we can already see that we will have some inputs, that is the other actor, the camera actor, and then we're also going to have a color, so let's create that. Color and linear color. Okay, there we go. Then we're going to get a canvas, and we're going to add the child to canvas. Okay, this is going to be the child. Then we're going to set the anchors of it. So set anchors. Let's split this. And for me, this is going to be 0, 0, 1, and 1. Again, you should test out and see which are going to work for you. And if you wonder why these values, that is because these are going to be on my entire canvas, right? On the entire thing, 0, 0, 1, 1. Okay. Then we're going to set offsets. And again, these were experimental. For my sizes, this will depend on what you have. So here I'm going to have 330, and then here 330. These values are equal. That is because I want both on the right and on the left to have the same amount of margins, of offsets. Okay, then we're going to get, for the return value, get slider, and let's make sure this looks nice, because messy blueprints always look bad. Okay, then we're going to set slider handler color. This is why we're going to have here this color. Plug this in here, and then we're going to also create a new array, which is going to store markers. So markers, array, and widget underline marker. Okay, and then we're going to add to this the return value of the create widget, and this is going to be used in order to remove markers later. Actually, not even later, we're going to do that right now. Let's get back into the first person character, and as I said, for the remove marker, what we'll have to do is to go here. From HUD, we will need to get a compass, and then get markers. Okay, then we are going to get another, get the get node with the ID, the input ID. Okay, and then we're going to remove from parent. All right, and plug this in here, and then we are going to remove index. So remove index, and this is an example of a very messy blueprint. Okay, and in the index the ID. Okay, hopefully it's readable. Let's compile, and now we will have to see how we are going to create the marker. So let's get into create waypoint, and everything will happen in here. Okay, so at the end, what we'll do is to get the HUD, then get compass. Get compass, there we go. Then I'm going to call create marker. For the color, I'm going to set the color of this function. Okay, then the camera actor is going to be my first person camera, and the other actor is going to be the other actor from the input. Okay, now one thing for our fun, let's go to color and let's break this down, and let's make here random float in range from 0.5 to 1. Copy this multiple times and set this in here. So now we're going to have random colors every time. Of course, you don't want this for your game. You might have an array of colors, and you can use those depending on how many waypoints you already have. So every time you increment to the next color, or based on the importance of the item, the quest, or whatever there is. Okay, let's press Q, and now we can see we have an error, and that is because we haven't set the accuracy. Let's get back into the widget marker, graph accuracy, and 0.75. I think that should be a good value. Compile and play, and now you can see how everything is working. I can get close and it is going to move. I can look at it and it is going to be there. If I'm going to press Q once again, it is going to disappear. I can press Q once again and it is going to reappear, not with the same color, just by chance it was similar. And now the last thing I promised you to show, that is what accuracy does. Okay, let's press once again, let's play and press Q, and you can see, right, just how it goes, how fast it can go, and that is because of the accuracy. So let's go back into widget marker, graph, and set the accuracy. Instead of 0.1, you saw a very low amount is going to move very fast, a very big amount is going to move slower. That is why I like 75, because it fits this bar, right? When it gets in the corner, it kind of gets in the corner of the compass as well. But there's one problem, I think. Yeah, as you can see, once it is going to get out of the screen, it is going to move to the right side, which is not what we want. Okay, let's go to event graph. And the problem is here. This should not be not equal, this should be actually equal to. If this is equal to 1, it is going to become 0. But if it's equal to 0, this should become 1. And in case you haven't understood why this is this way, 1 goes to 0 and 0 goes to 1, let me show you. Let's get into the designer and set the bar thickness to 3 so you can see it. So, if the slider value is not equal to 1, yes, which means it is somewhere on the left side, and it is behind the character, we are going to set this on the left side. But if it is not equal to 0, right, so it's somewhere on the right side of this, then we are going to set that to 1, because the object is behind us, but it's on the right side, right? That's the way you have to think about this part right here. And that's everything for today. If you have any other questions regarding this tutorial, let me know down below and I will make sure to answer them. If this is your first time here and you want to learn more about Unreal Engine 4 and game development, start now by subscribing so you don't miss anything. Big thanks to the Patreons of this month, those being Aaron Skinner, Andrew Millspog, Badr Al-Khahtani, Budiman Earthzone, Clive75, Donald Anderson, Drew Milne, Gabriel Martino, Justin Sorilli, Kawasin Thirotanan, Kiwi, Konstantin, Lorenzo, Quinn Shaw, Turik, and Xim369. It really means a lot to me. Thank you very much for watching this video until the very end, and I will catch you in the next one.